Hi everyone, welcome to episode 4 of the Exoskeletons and Wearable Robotics podcast. My name is Bobby and I'm with Professor Tom Sugar from the Wearable Robotics Association. And today we're going to continue on our overview of the different categories and applications of exoskeleton technology. So I believe last time we talked about industrial and logistics exoskeletons, Tom?
Yes. And it's good to see you again. So yes, last time we talked about industrial or occupational exoskeletons. And this time we're going to discuss military applications. So again, if you go to Exoskeleton Report and you click on the catalog, we'd like today to discuss different types of applications of military exoskeletons.
So you have worked on military exoskeletons, and I'm assuming a lot of the information is secret or it's behind non-disclosure agreements. So I think we should focus just on what's available in the public domain. So
Yes.
We'll primarily focus on past activities because of that. Just whatever has managed to surface its way into the realm of public information.
Yes. So for me, some applications that I have worked on in the past is we built some exoskeletons to reduce the load when you're carrying, let's say, a very heavy backpack. Some of these people are carrying 80, 100, 120 pound backpacks. And can you build devices for gravity compensation? We've thought about exoskeletons for energy harvesting at the ankles. We've thought about exoskeletons to help you push heavy objects. And we've thought about exoskeletons for lifting devices. I think those are some interesting applications.
Oh, what a great intro. So the way that I always think about the exoskeletons for defense is, like you said, that they can be battery recharging or energy harvesting, which was a popular topic for quite a few years. And it doesn't have to be necessarily an exoskeleton. A lot of the energy harvesting devices that we have seen have been like on the heel. On every heel strike, you try to charge a battery. I've seen like vibration compensation devices.
Mm-hmm.
So if you have people on a fast-moving vehicle like a speedboat with a lot of vibrations going, the exoskeleton will act like a shock absorber and try to soak up some of those vibrations away from the body. And like you said, we've seen devices that try to offload the force of gravity from the shoulders, from wearing backpacks, the kit. And we've seen devices that are similar to what we discussed for logistics and occupational, that help with load transfer and loading, unloading, doing repair work, manufacturing, some non-combat activities.
Mm-hmm.
And we've also seen devices that are more focused on lateral movement, applying energy and force assistance to get from point A to point B.
Mm-hmm. 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 So maybe let's start on one of those. On energy harvesting, I have seen people thinking about putting devices at the knee. So when you're walking downhill, so to give you an example, if you're walking downhill down the Grand Canyon, so you're walking down 5,000 feet, when you get to the bottom, your knees are literally shaking. So could you design a device, let me say, absorb the negative energy at the knee as you're going down, and then you could take that energy and store it in a battery? I think that's a really interesting device. Then I've seen devices store energy as the leg rolls over the ankle. You store that negative energy and you're going to and you're going to use that energy to, let's say, charge a device. So I've seen both of those. Quite interesting devices.
And I think we should maybe even lead with the why. Are we doing this just for the technology's sake? Or the problem that these devices are trying to fix specifically is that we have batteries for radios, we have batteries for potentially night vision, batteries for GPS location, batteries for flashlights. So a soldier, a defense contractor, a security person is expected to have more and more batteries on them, which is that additional weight which is being added and added and added.
Yes.
One of the questions is, well, can we reduce some of that weight by putting a energy harvesting device? So the battery is being charged during the duration of their mission or deployment or operational task. And one of these devices that has been explored, one or more, have been exoskeleton in nature, where they are connected between one or more joints on the human body.
Mm-hmm. Yes.
Do we want to talk about?
That's right. I mean, that's extremely important. I think, what I had heard is people are now want to carry, very sophisticated phones, that would get you extra. You could contact things, sophisticated phones, sophisticated radios, night glasses. Exactly. And the idea is that you would power, a battery pack, and then that battery pack could be used to power the mission. Exactly.
Well, come to think of some newer ones, like drone jammers. Those require energy and battery too.
Yes.
Or drone control devices. So the idea is how can we reduce the load, the weight burden on all of these batteries? Could we be harvesting the energy during movement? So Tom, do we want to talk about the drawbacks and why we are not seeing, at least in the public domain, we're not seeing huge adoption of this, or should we save that for a different segment?
Well, we could chat a little bit. I think obviously the drawbacks on some of these devices is I have to wear an extra device. Is it comfortable? Does it slip down the leg? Does
it generate extra heat?
Right. Does it generate heat? Dawn and doffing time, and I think that if you could integrate the device in with the clothing, and to give you an example, this would be for another topic, but there is some people thinking about integrating hip exoskeletons into clothing for hiking. I think once we get into that mindset of like it's going to be an advanced piece of clothing or an advanced shoe, so like you'll just have a shoe that's got hard points in it, so like the exoskeleton can just attach to the shoe and then detach from the shoe within 30 seconds. I think we'll see more of it, but I think that
maybe, yeah, I think that is now going maybe into different territory, which is what could be done in the future. Because off the top of my head, I can also see pushback. Like, let's say, it doesn't even have to be in a military, but let's say I have a standard kit for employees. Then does that mean I need to replace the standard kit so now it can integrate with an exoskeleton? So maybe that is one way to solve it. Maybe it isn't. Some of the feedback that I have heard is that it takes an enormous amount of walking to actually get to the point where now there's a net benefit. So the cost of carrying the exoskeleton, the cost of the discomfort it may or may not cause, having to fit the right device to the right person, so on and so on. These type of devices were popular, but as of late, at least, I have not heard anything new about energy harvesting over the last year or so. How about you?
I haven't heard anything new there. So I guess I'll end with, I think I did a calculation a long time ago, and it was about 3 hours of walking at the ankle. This was just an ankle device. It was about 3 hours of walking to charge, that average iPhone. And so it's tricky. So I'll end on this. Human beings don't realize how much energy we use and how much energy is in a lithium ion battery. It's impressive. It's very impressive.
And for everyone, this is just talking about past technology and the way that things have been approached in the past. We are not talking about what's currently being done, because for the most part, we don't know.
Right.
And we definitely don't know what new technologies and solutions will be coming down the pipeline in the near future.
Right.
But I think since we're talking about applications to military and defense exoskeletons, I think it's important to hit on all of these topics, that what has been tried in the past.
Right.
Because history has a tendency to repeat itself.
Right.
So more likely than not, we will see someone give it another try in the future.
Yes. We could joke for a second, especially in academia, we will redo something that's been done in the past, and we'll use the word novel device at the top. So it's funny. But okay, so let's jump to a second. Bobby, what device would you like to go talk about, or what category would you like to talk about?
So I think it's easy to talk about the ones where there haven't been too much news recently. So another category would be the how to describe it exactly, the vibration reduction or the shock absorber exoskeletons. And I've seen only one with a military application, which was for speedboats and race boats. So if you're on choppy water on a small surface craft that's 2 to 20 people, there's a lot of vibrations that go into the body, and a lot of that goes into the knees, where the knees are constantly trying to stabilize you, like a spring dampener system at the knees. And we will talk a lot more about these once we get to consumer and recreational exoskeletons, because those type of devices are still being actively sold and developed and used. I have not heard really of anyone working on this recently, but I think it's, again, important to bring it up and say, hey, people have tried to do that in the past. One complication.
There was a company, I don't know if you have basically a directory of exoskeletons companies. So there was a company, I think it was 20 knots or something, that was interesting.
Yes, really good memory. Right. I've started, so they used to have a catalog entry. I have since retired it and removed it from the catalog, because now it's older, and to the best of my knowledge, it's not being worked on. Of course, I could be mistaken with these things. You never know exactly who's working on what, but at least as far as the information in the public domain is concerned, I don't believe that there's still work being done on that. And on the flip side, to touch on some of I think it would be remiss not to talk about the concerns that many authorities have had with the opposite effect, that an exoskeleton could potentially be taking vibrations and propagating them through the structure of the exoskeleton device itself.
Right. There was experts that, working with ASTM, were thinking about this idea that if I have a rigid shoulder exoskeleton and I'm holding a device that's vibrating, then that rigid exoskeleton could put vibrations into the lower back. And so I think that is a topic that, always want to think about. We always want to think about what can these devices help, where are they helpful? But we want to make sure we think about the drawbacks, right? Because as an engineer, there's always trade-offs, and you want to make sure we do our best.
Yeah, I think you're referring to the work of Don Peterson.
I am. I'm referring to the work of Don Peterson.
And
outstanding.
Yeah, and in the previous episodes, we have not gone into the negatives, drawbacks, or concerns that have been voiced by professionals and experts on exoskeletons, just so we don't complicate the conversation and make things really confusing. But I think now that we're on episode 4, we can slowly start to ease ourselves in and make things a little bit more complicated and be able to begin to communicate some of the more complex topics and some of the concerns that have been raised, and start to explore, if this exoskeleton technology is so great and so awesome, why aren't we seeing it everywhere?
Right. Maybe Bobby, let's jump on to another category of military exoskeletons. Well, which one would you like to go to next?
Why don't you choose?
Okay, so why don't we think about devices that are used to hold up heavy backpacks? So you can imagine systems that go from the backpack all the way down to the ground. You can imagine systems that maybe stop at the waist and things like that. So I can maybe show a picture of one or two things. Like you can imagine a device that's attached to the backpack and that goes all the way down to the ankles and reduces load. If I go back to stuff, you can imagine some work that can offload backpacks off of the spine down into the waist and things like that. So I think there was a lot of work being done in this area where soldiers, need to carry 120-pound backpacks. We know there's musculoskeletal injuries. You can find journal papers and articles describing some of the leading causes of military infantry leaving is, the musculoskeletal injuries. We do know that this is an active topic. They're working hard on this in Europe again. And so in Europe, and there's some NATO projects in Europe thinking about some of these devices.
Some people call them like gravity compensation or gravity redistribution devices. So if you think of human motion, you basically have two components. You're fighting against gravity to stay upright, and you also have to create linear motion to go from point A to point B. So these devices are specifically focused with the first part of the aspect, which is helping with gravity compensation of all the loads, which could be back those same batteries that we just talked about, could be body armor, could be helmets, could be ammunition, could be food, could be a lot of things that you're expected to carry. And like you said, we are seeing now a rise of activity in research and development of this family of exoskeletons, and I am seeing news come from India, news come from Canada. So it's not just Europe, but we're seeing multiple countries get in on this. We've seen multiple prototypes from Russia as well over the years. It is a good problem to try to solve.
Right. It's a good problem to try to solve. Since we're also talking about some of the drawbacks today, some of the drawbacks were that does the device get in the way of your legs when you're moving, where the device certainly helps vertically, but the human being is so adapted to walking that, you don't want to mess up the gait cycle. As the gait cycle is moving back and forth, you don't want to mess that up. Secondly, again, are these devices paying for their weight penalty? So I wear this device, I add on an extra 10, 15, 20 pounds to a device, and people are like, well, I'm already carrying 100 pounds, and now you're making me carry an extra 20 pounds. That leads me to some thinking that I have done in my research with the U.S. Army and the Air Force. I like to say to people, the robot's got to be less, or the wearable robot or the exoskeleton, whatever you want to call it, but it's got to be less than 5, 6, 7, maximum kind of 8 pounds. Otherwise, people just don't want to wear it. And so that would be kind of a drawback. 2 drawbacks. There's got to be in the right motion, and it's got to be lightweight.
We've definitely heard feedback like that. Well, I've heard that feedback more for localized exoskeleton systems. I haven't heard too much feedback about devices that try to offload some of their own weight into the ground, because depending on how the exoskeleton is made, it's trying to offload the weight of the backpack and kit, but it's also trying to offload its own weight as well into the ground.
Yeah, you make if you go all the way down to the ankle and down to the bottom, to the sole of the shoe, you'd like to offload the backpack and the motor weight and things like that to the ground. Yep, that's a good point.
You're completely correct on the transparency. And does it feel like we've heard feedback, and this is really ancient feedback now. So warning alert to everyone, we're dating ourselves. But some of the really old feedback from a decade ago was people felt that they were swimming in these devices rather than walking in these devices.
Right. Like you're walking through a swimming pool.
Right. Some of the feedback that I have heard is you're offloading the weight. So that means that the exoskeleton now has its own ground contact point. So does that ground contact point interfere with how the user perceives their own ground contact point? And does that ground point, how does the exoskeleton deal with soft terrain like mud or uneven terrain? So in the past, 10, 15 years ago, there was a lot of activity, a lot of enthusiasm about these type of devices. Then they stopped for a few years. We didn't hear much in the public domain. And I think new technology, new ideas have been incorporated. And now again, we are seeing multiple companies pumping information out that they're actively working on solving this issue. And going back to people, we are overloading. From the best of my understanding, there's a lot of overloading happening, and it doesn't have to be in an active combat situation. It could be during training, it could be during maneuvers,
yes,
it could be during logistics. So we have the technology, we have the capability to try to do something about it. There was a project to try to make bomb suits more comfortable.
Right. So that would be similar to exactly what we're thinking about. I know of projects, right, to think about bomb suits. I also know of projects, we were working on a project where even when you're carrying an IOTV vest with body armor, it's about a 35 pounds of, let's say 35, 40 pounds of body armor. And can you build a hip exoskeleton to help offload some of that weight? So that's extremely important. I think, Bobby, you made an extremely important point. It's not that, hey, I need a device, let's say, for combat. It's I need a device when we're just doing maneuvers. We're walking from one point to another point. We're moving things. We're moving heavy backpacks, or I'm just wearing an IOTV vest with 40 pounds and I'm walking around, and can I reduce the fatigue? And I think those are important, really important points where we know that when you're wearing 50, 60, 70 pounds, it can damage the body, the back, the legs, the knees, the ankles, right? And so people are having these musculoskeletal injuries. And I think you made a really good point about that. These devices don't need just to be in combat. They could just help when you're, doing a maneuver, just walking with 40, 50, 60, 70 pounds. Yep.
And I think the bump suit is a good example where it's a combat application, but not necessarily an active combat zone. And I was really fortunate to be at the ASTM Center of Excellence Exo Games, because they actually had a bomb suit, a real bomb suit for students to try on and to challenge them to think how can their exoskeletons integrate into the already existing bomb suits.
Right. One last suit that I'll talk about, and then maybe we'll go to another topic, is people carrying heavy oxygen tanks. So imagine you are working in a dangerous environment. You're working in, with some chemicals or asbestos, or, it's just a dangerous environment. And you're carrying heavy tanks. And so they're the Department of Energy, and so this is was interested in that area. And so there's some very good work in Georgia and Florida in that area.
Yeah, and going back to the ETCOE Exo Games, that was also one of their focus. It was on first responders.
Yes.
So they definitely encouraged all the teams to think about how the exoskeleton could integrate with an oxygen tank or even two oxygen tanks.
Yep.
And speaking of Department of Energy, we've got another need for nuclear facilities, nuclear waste disposal facilities as well, where you have a really heavy kit of protective gear. And the way that I have heard it described in presentations is there's an enormous amount of fatigue. So the way it's been described to me is that it's a trade-off. You want to get as much of the work done as possible, so you're not decontaminating, getting the equipment dirty again, decontaminating again. But there is so much fatigue from the weight of all of the protective equipment that they cannot do work effectively for more than an hour or an hour and 15 minutes before becoming completely exhausted and having to get out. So imagine having a gravity compensation exoskeleton, which now offloads some of that weight of the protective gear into the ground. Yep. You can now go in with one entry or just fewer entries, be able to work 2 hours, roughly speaking, without fatigue, which now reduces the number of times you need to go in and out, contaminate and decontaminate, be exposed to dangerous materials while you're walking to the work site and back from the work site again and again and again. These devices are trying to solve real-world problems and help people. They're not just technology for the sake of technology.
You bet. You bet. Okay, so maybe we'll jump on another topic I'd like to talk about. You talked about laterally moving objects. So I wanted just to give a couple pictures to get the people to think about in their mind what's happening. So I was on a project where we were thinking about powered hip exoskeletons to move these very heavy, like 10,000 pound crates. And to give you some examples, like people are pushing, two people pushing, one person pushing with their back, they're pushing with all of their might to get these objects onto airplanes. And so imagine the inside of some of these airplanes. It's enormous. It's absolutely enormous. So you are building, 2-story crates that are 10,000 pounds where you have to push these things on. And so this is real world tasks, a person pushing with their back, 3 people pushing as hard as they can pushing. So I wanted just to show some pictures just to get people to understand that there is tough logistics tasks that you need to perform. So how do you, and this is related to industry as well, occupational exoskeletons, but how do you help people do their daily work? And this work is occurring daily. We know that it's tough, right? We're asking people to push at extreme limits. Any thoughts?
And yeah, maybe you can go back to the first image. So for those that are just listening in, so this is the inside, or this is going towards a cargo airplane to execute an airdrop, I assume.
Right. And so basically, you do have fork trucks, you do have forklifts, you do have trucks. Forklifts will go and pick up some of these crates and get them to the site. But once you're inside the airplane, you've got to push these things inside the airplane, because it's about basically weight. So they don't have robotic devices inside the airplane. And it's about size, right? You got to get as much as you can on that plane. And you basically try to unload 40 or 50 of these crates as fast as you can. And then you load 40 or 50 crates back on as fast as you can. So it's very tough work.
So this will be an example now of the second subcategory where we've talked about gravity compensation. Now we're talking about helping people get from point A to point B.
Yes. So we're helping people to get from point A to point B, and they're lifting objects or they're pushing objects.
So then maybe we should divide this into 2 categories, that we still have the logistics applications with lifting.
Yes.
Lifting, assembly, disassembly, where everything that we talked about in the previous episode for occupational exoskeletons would apply.
Yes.
And in addition to that, we have lateral movement, get from point A to point B with the gear that you have.
Yes.
Right. And there we are seeing a lot of localized exoskeletons that are at a specific body part. And we've seen different companies from all over the world now do ankle exoskeletons, knee exoskeletons, hip exoskeletons, and lower back exoskeletons, which and even some applications now, come to think of it recently, of shoulder exoskeletons, which are used for logistics and for movement.
Right. So, for example, at the ankle, you could power the ankle and give you power push off. At the knee, you, instead of damping at the knee, you could actually power the knee. So people are working on pneumatic devices to power the knee to get a power pushing forward. Because technically, to be honest with you, they don't want you to turn around and use your back, because then you're not in control of that large crate. They'd like you to push from a forward movement. But when you're pushing from a forward movement, you have to have a strong arms, you have to have strong back, you have to have a strong hip, and you have to have strong knees. And so people are powering the knees. And then what we were doing was powered pushing with, so it wasn't even just a hip exoskeleton for a squat lift. It was a hip exoskeleton that could help you do a powered push, and in that sense. And so exactly what you're talking about, Bobby, that people are thinking about, how do I strengthen the ankles? How do I strengthen the knees? How do I strengthen the hips? How do I get a strong core? So how do I strengthen the lower back? And then lastly, yes, how could I even strengthen the arms for power pushing? Quite.
And to the best of my understanding, if we're talking about walking on a relatively flat surface, powering or actuating the ankles and the hips will give you the most value. If you're going on an incline up, incline down, or if you're dragging something behind you, and now you yourself are leaning forward, then devices at the knee is where you can get the most value out of them. Do I have that correct, Mo?
Yes. Yes. When you were going uphill, you need some definitely knee power. But if you're on flat ground, the torque is mostly at the ankles and hips. But I am going to make this one comment. As you get older, let's say into your 50s, your knees are sore. And I'll just say that my knees are more sore than my hips and my ankles. So anyway, just as a funny comment. So.
And then anything else we've missed? Because just looking right now at the picture that you have in front of us, I'm realizing that we forgot the different experiments we've seen with neck exoskeletons, which is to take the weight off of the helmet, off of the night vision goggles, off the radio communication and GPS, and not have it all be on the neck, but have some sort of a mechanical device that takes that weight and drives it towards the shoulders and to other parts of the body. So just bypassing, it's not really taking the weight from one part of the body, putting it into another, but bypassing like the injury point.
Yes. So I'm trying to summarize in my head for a second. Yes, there's devices for energy harvesting, devices for vibration reduction. There's been a lot of hip devices for logistics. So just like in occupational exoskeletons, if you need to move ammunition, which is heavy, if you need to move crates, because actually, so speaking of that, someone has to make those 10,000 pound crates that I was showing. Someone has to make those crates. So they make those crates. And so you have to pick up boxes, make those giant crates. Then a fork truck brings the 10,000 pound object to the airplane, and then you got to push that thing onto the airplane. I think that there's been I think we talked today, Ben, there's been passive devices, there's powered devices.
And you have gravity compensation, you have logistics, and you have help with getting from point A to point B, just focus on the linear motion. I think one thing we should mention is that for many years, there was a lot of work to try to do a combined device that does almost all of these things, that it has the gravity compensation and linear motion and be able to assist with logistics and it be all in one. But I think we're seeing a trend where we're moving a little bit away from that.
I do think the trend is for, some simpler, lighter devices, whether it's powered or passive at the hip or powered or passive at the ankle. I think there is a trend, towards that. I mean, certainly there was in the initial work, and it was fantastic initial work, and all the initial work, in Boston, in the soldier work, in Natick and things, they were working on, what was possible, what can we do, what can we build, and I think some of those were just, complicated and costly, and so people are thinking about now, what can I do to really help soldiers, let's say, doing logistics. And actually personally, this is a personal opinion, so please only, and don't get mad at me on it, but as a personal opinion, I think that exoskeletons trend is moving more into the logistics and operations, and what can we do there first, right? And then what can we do with help the combat soldier I think that'll come back again. But I think logistics, let me say it this way. I think that there's devices that are commercially developed that can help in military logistics. Anyway,
we are dealing just with what's publicly available in the public domain. And there's always a time delay on that by at least 1 or 2 years. So these trends that we're talking about, they're not future trends, they're past trends. This is what we've seen happen and what's been talked about. So what is really happening behind the surface right now, or what direction things will take, we don't know.
And certainly as a robotics, person, as a wearable robotics person, I'd love us to work on a suite of devices, work on powered and passive ankle, powered and passive knee, powered and passive hip, strengthen the core. I'm actually a big believer in that lately. And then go to these really, powered systems that could really help, in carrying heavy bomb suits and things like that. I'd love to see that continue work. We'll see where it goes, and I think that and as batteries get better, as microprocessors get better, as actuators get better, super motorized systems, I'd love to, to challenge the community to keep working in that area.
Yeah, so that's from the technical engineering point of view. And I think that here it would be a good point to mention that I got to go to the Computer History Museum, and there's a really wonderful chart there that showed that year after year, every year, the cost of microprocessors was reduced in half. And then the next year, reduced in half, reduced in half, reduced in half. And I think it was from the 70s all the way into the 2000s. Sadly, we don't have that rapid reduction of cost of exoskeleton technology, but we are seeing a reduction. Wearable sensors can become way cheaper. Gyroscopes can become cheaper. Things are getting...
the technology has gone down, but we haven't seen the reduction in the cost of what I call servo motors. So it's a motor that has that reacts to people's motion. So you have to have sensors, you have to have microcontrollers, you have to have sophisticated
I think management. We can definitely go into that, but for the listeners, to emphasize here, we are seeing a reduction in the cost to make these devices, but it's not the same as it was for the digital revolution, where year after year the cost of microprocessors just went down by half, went down by half, went down by half. Unfortunately, we're not seeing that when we're talking about all the components that it takes to build exoskeletons and then evaluate them. Going back to the human element, it occurs to me there's two other intersection points. There's another intersection point between logistics ergonomic solutions and military exoskeletons. I've heard an example about using chairless chairs. Mm-hmm. That if you're at a forward operating facility and you're told to strip the paint off of an airplane, you don't necessarily have pits or a good place to work at. So you have to do it while you're crouching. You have to do it while you're squatting. You have to do it while you're kneeling. Mm-hmm. And that causes you do 1, 2, 30 airplanes. That causes injury. And we end up injuring servicemen for the rest of their life in order to complete logistical tasks. So I've had people explain to me, what is this, a chairless chair? I really wish I had that when I was in the Air Force. And I think another intersection point is with the medical and Rehabilitation Exoskeletons, Department of Veterans Affairs in the US has been one of the first major institutions, at least that I know of, that for decades now has had a laser focus on medical exoskeletons and what can they do to help veterans and servicemen that have already been injured.
That's extremely important. Whether it's a service member that, had a spinal cord injury from active duty, or it's a service member that has had a stroke and, they're older and they're in their 70s, 80s, and 90s, and mobility is so important. If you're sitting in a wheelchair, it's hard. And if you can get people up and walking and doing things, it's important. It's extremely important. And that's a great point, Bobby.
So maybe, so that's a little preview for our next episode, which will likely be on medical exoskeletons and what can they do. Yeah, our contact information is on both our websites. On the Exoskeleton Report at the bottom of the page, it's contact us. Alternatively, you can just shoot me an email at hello@exoskeletonreport.com. Same thing with Tom, the Wearable Robotics Association. The contact information is right there on the website. Don't hesitate to reach out, or if you want to be a guest, or if you have feedback, want to participate, want to help assist with making a better podcast, we are just getting started here. Nothing is set in stone.
We could use help and support, and thank you very much. And Bobby, I enjoyed the conversation as always.
Oh, the pleasure was all mine. Thanks for your time, and I hope everyone who listened to this had a glimpse of the problems that exoskeleton technology is trying to solve and what has been done in the past, and the different ways of thinking that have been approached by entities from all over the world. Thanks, Tom.
Thank you. Bye-bye.